Hello everybody, this is Mr. White and I just wanted to show this video over completing the dynamic maze on the vrvex.com. So if you are looking, paying attention, I'm at vr.vex.com. It's right there, right here. Okay, so focus vr.vex.com. Got it? All right. Okay, so what I'm going to do now is I'm going to open up the playground. The objective would be to complete not the hidden pixel art, but to work on the dynamic wall maze. This is a task that I gave to everybody as a superfluous task. It's a meaningful thing, but something that I had people work on just to see if they can complete it. Now, I will warn you that the program that I'm going to show you is not the most efficient program, but it might be the most concise program to do this. So there's a lot more elegant ways to solve this. I even saw some of you students do those things where it's like pretty neat to have you guys think of your own ways to solve this maze. So the objective is to get your robot to drive through the maze and end up on that checkerboard platform thing. That is if I look at it in this view, it is something that's on the ground. Now there is this border here, so I guess I might want to be warned that if my robot does end up seeing that, I don't want to stop and ruin my program. So it might do that if I put a certain thing in there, which I'm actually going to do. I'm not going to worry too much about that. So you will see that there's a way to enter the maze. That is a challenge where some of your programs might cause the robot to drive off the maze. So let's start and look at our robot. Something that I see some students doing, and it's probably a good thing to actually do, would be I'm gonna move myself over. I don't know. I'll just get rid of myself. Maybe I should maybe I should go back on. Okay, whatever. Fine. I know some of you are like, Mr. White, we want to see your face. Fine, fine, guys. All right, here we go. So I'm going to go to the drivetrain here, and I'm going to turn up the speed. Right now, I'm going to turn up the velocity. Say yes, set it to 100%. 100%. Why don't I set it to 1,000%, Mr. White? It only goes up to 100, so don't even think about it. Set drive velocity to 100%, set turn velocity to 100%. Not a super major thing to do, just something that is kind of cool. Might as well put a pen down there because sometimes it's kind of cool to see the path of your robot. So I will move the robot pen down as well. So just robot's going to start, move the pen down. Okay, this little bit here is something through troubleshooting that's caused saved a lot of things from preventing my robot from running the code and then falling off the end of the starting point. So I'm just going to turn the robot to the right 90 degrees at the beginning, and that's what I'm going to start my initial program on. So what I'm doing right now is I'm just setting the speed of the robot to be faster than it is at 50%. At 100% speed, 100% of its max speed, it is going to go move the pen down, start tracing its path, and I am turning it 90 degrees to the right. So I am going to do that. The next thing I want to put down here is a loop. So I want it to run this program until it's done at the very end. So I am going to put a loop with a condition. And the condition is that you're going to run this whole thing until you see red below you. And that red would be that checkerboard. So we want to stop at that checkerboard. So there's a while loop that we're going to run. So I'm going to go over the control button here, click on control, and scroll down to a while loop here, and drop a while loop in there. So let me zoom in there. There's a while loop there. See that? It's been a while. Oh, no, that is a while. It's a while loop. So I'm going to move this over so I can zoom in a little bit here. So the robot's going to run and do whatever code's in here when this condition is true. So what condition can we have it be true? that it will run until it sees this. So that would actually be if I don't see red, then keep running the program. So the red below me is what I'm talking about. So I'm going to write if I don't see red. So if you naturally say, oh, when I don't see something, then run this. In this program, it's a not. Like when there's not a sensor, so not is the operator, the green. When there's not a sensor that can see red below me. So I'm going to take this thing and say not down eye. When the down eye does not see red, run the program. Run this whole loop here. I'm zooming it out and just get used to finding the right spot. Here we go. Maybe a little farther out. So now we have hey, there's a while loop that's going to keep going. This loop's going to keep going until I see red below me. Oh, that's pretty good. So I want to drive forward. Unless I see something in front of me, then I don't want to drive forward. I want to do something else. So that would be an if statement, right? That would be, hey, if an if-else statement. I know I'm going to do an if-else statement. Hey, I want to drive forward. So in this while loop, I'm going to nest an if-else statement. If this condition is true, then do this. Anything else when that condition is not true, do this. And that'll be on repeat until this while loop is met. So as long as that condition can be met and then not met and then met again. It's not like it's going to continue the whole time because within that loop. So it's a powerful if statement here, if structure. So what are we talking about? What's going on? What do we want to do? Let's focus on what we want to do. Well, we do want to drive forward. We want to drive forward. And we want to drive forward at a distance where, hey, I'm going from there to the center of that spot there. So if I wrote 200 here, that's each of these blocks, like these squares. You can kind of picture a square right here, square right there from the spot there. They're 200 by 200 squares. So I want to actually move from the center of this square to the center of that square. Around 250, I'll put 255 in there just to give it a little tolerance. I'm going to drive forward 250. I'll test this program in a second, but there's no condition to test it. So I'm going to drive forward 250. Now, I did say something about, and then maybe I'll put a turn right in here. We'll just see what this does. I'll turn right if I'm not driving forward, I'm going to turn right. But it's not really if I'm driving forward. It's if the condition is not met, then do something else. If it is met, drive forward. What condition are we talking about? Well, we're talking about something that we see in front of us, the wall, okay? We have sensors that shoot out and they can see the distance we are away from the wall. So we're going to do that. So we're going to go down to operators, and there's going to be this, hey, if you're greater than, and we're going to change that 50. What are we talking about? Well, we're talking about distance in millimeters. So if we're greater to 50, drive forward. Let's see if this works. I'm going to run the program. Oh my gosh. It's working. Oh, wait. Many times it'll get stuck in a little situation like this. So it is going fast, you saw with the velocity, and now it's stuck. It's getting in this thing here. So let's talk about the maze and what we really wanted to do. So I'm going to restart here. Notice how it changed, the whole maze changed because it's dynamic. But what we're looking at here is if you think about solving any maze, you can follow one side of the maze. It's like an old trick to do any maze. If you follow one side, eventually, like if I follow the right side, eventually I'm going to loop around and complete the maze. Now you might be like, but that's not an efficient way. I told you at the beginning this is not an efficient way to go through the maze, but it is efficient in the sense that it will complete it, but it's not efficient in the sense that it will complete it in the fastest time. So We are going to write a brief program that will complete it eventually, but it might not be the quickest way. So what do we have a problem? We had a problem where we got stuck. So basically we have to look another way. We have to say, hey, you have to look somewhere else. So you have to scan another area. So in this if statement, I'm going to move this up here. I'm going to say, hey, I want to drive forward for 255 millimeters and then turn right. So what I'm essentially doing is I'm scanning to the right. And remember, if I scan to the right and this ends up being less than 250, then it'll move down to the next thing. So if there's something in front of me, I'm going to move down the next thing. So I will run through this program one more time and just verbally tell what's going on, and then we'll run it. Anything when that's no longer true, when that condition is not true, I'm actually going to turn left now. I'm going to say, whoops, I'm going to say left. I want to turn left. Delete this. I'm going to delete that. So what this is going to do now is we'll run through it. So at the beginning, it turns on speed fast. It moves the pen down. That's great. And then it turns right. It turns right 90 degrees. A lot of times what that does is going to prevent from getting in a loop and basically driving back and then falling off the map. So we don't want to do that. But really what we want to do now is it turns right, and then it starts this loop and says, hey, if the distance in millimeters is greater than 250, then drive forward. That's basically, if there's nothing in front of me, drive forward. So this is nothing in front of me. Picture that. That's the condition. If there's nothing in front of me, drive forward for 255 and turn right. If there's nothing in front of me, again, drive forward, turn right. There's nothing in front of me, drive forward, turn right. There's nothing in front of me, drive forward, turn right. It'll do that. It'll keep going through this right here, this if statement with this loop a bunch of times. And as long as this condition in the if structure is true, it'll just drive forward and turn right. Not turn right and move right. Notice how it's not, hey, turn right, move right. A lot of times, if there's something there when it turns right, what am I going to do? It's going to say, hey, now you turn left. Let's see if this is going to work. Okay. So again, if there is something in front of me, I'm going to turn left. Let's see. All right. So I'm going to run this program. It's going to turn right, go forward, turn right, go forward, and turn right. Okay, there's something there. Just drives forward, turn right, and turns left. So turn right, there's something there, turn left, there's something there, turn left. So eventually it'll go through this. Now I'm going to pause this. Just press stop. I think I'm going to be successful at this. I think it's going to get to the end. So I'm going to do a little celebration. Like I watched a video of doing this, by the way, and it did have a little celebration at the end. And I was like, man, that's a pretty good idea. So why not do a whole like turn right, 270, turn left for 360. Sure. Let's see if we're going to win. Let's see if we're going to celebrate. All right, I'll play. Keep going. So again, what it's doing, you can see what's lit up right here while it's being mazed. Hey, I'm going forward, turning right, nothing's in front of me, drive forward, turn right, something's in front of me, nope, turn left. Something in front of me, nope, turn left, keep going, something in front of me. So it's checking. Oh, what happened? Ooh, it kind of got off there. Let's see why we think it might have done that. I don't know why I did that at the top there. So it's just driving forward each time and checking. This is the worst maze for the time here because it started right and it's going to loop around and hopefully get down here. This will be a hard one. I wonder if it'll actually make this one. So it's just going to check. It's doing this thing. Drives forward. It checks right. Goes this way. Again, it's not the fastest way to solve the maze, but it will solve every maze is to follow one side of the maze all the way through. So it's just hugging the right side of all these walls and moving through. So it will end up getting here. So now we can kind of see this robot solving this problem. Now it is going to kind of get back here, do this little thing. It's like, hey, where am I? So we just wrote a program, hopefully that you guys wrote this similar program that's going to solve this little maze. So you do that. Make sure you have a maze that, or you have a robot that can complete this maze. That's one part of the task. The second part is the other challenge. I'm not going to give you the answer of doing that, but please read the directions. And let's see. Boom. All right. Look at that. Now I'm turning because my while loop is over, and now it's just spinning, doing a celebration. Yay! So we just did it. Wonderful. Time was around 2 and 20 seconds or 2 and 25 seconds. Pretty cool. Maybe with a different maze, if I restarted it and ran it again, I have better luck. Not this one. This is not a good maze for do again. Now, if you look at the maze, and I went, ooh, I want to hug the left side. I can switch all these right to the left at the beginning. Maybe I'll be more successful. And I'd say, ooh, I can get a faster time with my submission if you're going to submit this. If I decide to do this, hug the left wall. A lot faster in this case. So I just reversed each of the turning thing, and now I'm hugging the left wall after looking at the maze. I'm running the program. Now, what is this? Is this a closed loop or open loop system? It is a closed loop system. I am getting feedback from the environment around me. Okay, if I'm sensing things and I'm saying, hey, there's something in front of me, turn. I am driving. Look at this thing. This is going to be a fast one. Under a minute? Is anybody thinking under a minute? Come on. Come on, robot. I know you can do it. I know you can do it. Oh, no. Under a minute. Come on, under a minute. Oh my gosh. I think I did it. Anyway, there it is. Almost a flawless victory here, Mortal Kombat style. But nope. So the objective would be first task to rewrite this code, or you can modify the code whatever way, have a more elegant solution. But I think this is a pretty precise way to do this code to complete this maze. I mean, precise, it will work every time, but maybe not as fast as you want to be. So I don't know if there's ways for you to make it faster. Give it a shot. Okay, that's the first part of today. And follow along with the next task to see the other parts. Okay. See you soon.